So we are going to start photoelectric effect. As we know, Maxwell defined the wave nature of light, and Planck defined the particle nature of light. Here in photoelectric effect, we can see the particle nature of light. So let's just give a brief description about photoelectric effect. Let's draw a glass tube, and here one metal would be here, and here one electrode is here. Okay. This electron is considered as anode. As we all know, anode are positively charged. Okay. So here, when the light is incident on the metal, this metal is considered as photosensitive metal. Photosensitive metal. What does it mean by photosensitive metal? That means when the light is incident on the metal, it will eject electron. That means the photosensitive metal. We can take any metal which is photosensitive here. This circuit is connected with a battery. Why do we need battery here? We'll discuss later in this topic only. So when the light would incident on this photosensitive metal, this metal would eject electrons, and this electron, we know, is negatively charged. It would travel towards the anode, and that's how the current would produce here, and this would come in this direction, and we can see a photo current. This I is considered as what? Photo current here. Okay. So the next thing is, why do we need this battery here? As you know, if the light would incident on this metal, this electron would eject, and this electron would easily travel towards anode. Why do you need battery here? Here we would introduce one term which is known as work function or threshold energy. Okay. So what is work function or threshold energy? This electron is bind with this photosensitive metal with certain energy. Obviously, if we are considering, just for example, if we are considering 5 electrovolt is the energy, certain energy, and the light is incidenting on this metal. If we have more than 5 electrovolt energy, this light, if it has more than 5 electrovolt, then this electron would emit from this metal, and after that this electron would travel towards anode. So here we would get an equation EI equal to 5 plus KE. This equation is known as photoelectric equation. EI, energy of incident light. What is phi here? Work function. What is work function? The minimum energy, the minimum required energy, that would be better, the minimum required energy to emit electron from the metal. That means this much energy is must needed to occur the photoelectric effect. The minimum energy required to emit the electron from the metal, that is our work function or threshold energy. Just considering, if we have 6 electrovolt, okay, if we have 6 electrovolt, what? EI, assuming, and we have phi equal to what? 5 electrovolt. That means we need 5 electrovolt to eject an electron, and we have 6 electrovolt. At that time we can write EI equal to 5 plus KE, and with the value, we know the value of EI 6, phi 5, and plus kinetic energy. That means here we can find kinetic energy is equal to 1 electrovolt. That means after ejecting the electron from the metal, this electron would travel towards what? Anode with 1 electrovolt kinetic energy. Suppose we have EI equal to 5 electrovolt and phi is also 5 electrovolt. At that moment, EI phi plus KE. At the time KE would be equal to 0. What would happen? The electron would eject from the metal, but it won't travel towards anode. At that moment, this battery, or you can say cell, would ensure that this electron would travel towards this anode. This battery would help this electron to reach anode. Otherwise, this electron wouldn't be able to reach anode, and we won't get any photocurrent here. Okay, here we can define few more parameter like threshold frequency. What is threshold frequency here? The minimum frequency which is needed to eject electron or to occur photoelectric effect. As we know from Planck's quantum theory, energy is equal to what? H nu. So we can write from the photoelectric equation H nu equal to H nu naught plus kinetic energy. This nu naught is what? Threshold frequency. From this topic, we can get a lot of numerical questions like how to find kinetic energy from this equation, how to find velocity of electron. How can you find velocity of electron? If you would write k equal to half mv square, from here we can find the value of v. So we can get a lot of numerical from this topic like finding of threshold energy, finding of kinetic energy, sometimes finding of nu, that means the incident frequency of the light, and sometimes velocity of the electron. So we will discuss later down numerical portion. So this much topic would discuss it for electron effect. Thank you.